You are 35,000 feet above the ground. Outside your window, the wing stretches into the light. And then you see it. The wing is moving. It bends upward, slowly, quietly, and your stomach tightens. Everyone has watched this happen. The tip of the wing rises, sometimes by several feet, and for a moment the mind whispers a terrible question. Should it be doing that? We are taught to trust solid things. A bridge that sways feels dangerous. A building that leans feels doomed. So a wing that flexes seems like a warning, a crack in the illusion of safety we carry into the sky. But here is the truth that reverses everything. That bending is not failure. That bending is the design. The wing is not fighting the air, it is dancing with it. Every upward flex is the aircraft doing precisely what its engineers spent years perfecting. The movement you fear is the movement that keeps you alive. Consider the numbers. The wings of a Boeing 787 Dreamliner can flex upward by more than 3 meters at their tips during flight. That is not an accident tolerated by the design, that is the design. A rigid wing would be a brittle wing. A wing that refused to move would be a wing waiting to break. Flexibility is strength wearing the disguise that frightens us. To understand why, we have to understand what a wing actually is. Not a solid slab of metal. Something far stranger and far more clever, hiding beneath a smooth skin. Because the wing you think you are seeing is not the wing that is truly there. The strangest part was still coming. Peel away the smooth aluminum or carbon skin, and a wing reveals its secret. It is not a single piece of anything. It is a skeleton. Running the length of the wing is the spar. The spar is the main structural beam, the backbone that carries the weight of the aircraft. Most large jets use 2 or 3 of them, front and back. Crossing the spars are ribs. Ribs are the shape supports that give the wing its curved profile, the airfoil shape that generates lift. Between them, thin sheets of stringers add stiffness along the length. Over this frame stretches the skin. The skin is the outer surface, and on modern aircraft, it is often carbon fiber reinforced polymer, a material woven from carbon threads and locked in resin. It is lighter than aluminum and far more willing to bend without breaking. Here is the elegance. Every one of these parts is engineered not to be stiff, but to share load. When force arrives, it flows through the spars, spreads across the ribs, and distributes into the skin. Think of a fishing rod. When a fish pulls, the rod arcs. That arc is not weakness. That arc is how the rod survives a force that would snap a broomstick. A wing works the same way. It arcs to survive. The wings of an aircraft must hold up something enormous. A fully loaded Airbus A380 weighs around 560 tons at takeoff. All of that hangs from 2 wings. So the wing bends because it is built from parts designed to move together, absorbing pressure the way a rod absorbs a strike. But why does bending actually protect it? That answer lives in the physics of the air itself. In flight, the air does something invisible but relentless. It pushes upward on the wings with a force called lift. Lift is the upward force created by air, moving faster over the curved top of the wing than beneath it. Lift is what holds the plane in the sky, and lift does not press gently. On a large jet, it can equal the entire weight of the aircraft, hundreds of tons pushing up along the wing. Now imagine that force meeting something completely rigid. A stiff structure has nowhere to send the energy. It concentrates all that stress into single points, and stress concentrated is stress multiplied. That is where cracks are born. A flexible wing does the opposite. When lift pushes up, the wing bends up, and in bending it spreads the force across its entire length. The energy is absorbed, not trapped. Then comes turbulence. Turbulence is sudden, chaotic motion in the air, pockets that shove the wing up and drop it just as quickly. Each jolt is a hammer blow. A rigid wing would take every hammer blow at full strength. A flexing wing lets the impact ripple through and fade, the way a spring softens a shock. This is why engineers speak of a wing as a controlled spring rather than a beam. It stores energy in the upward flex and releases it smoothly, returning to shape again and again, thousands of times per flight. Metal and carbon fiber both have a limit called fatigue, the slow weakening that comes from repeated stress. Flexing keeps each individual stress low, which pushes that limit far into the future. And yet, the most common belief about wings gets this exactly backward. What people fear is the very thing keeping them safe. The mistake is understandable. We assume that stronger means stiffer, that the safest wing would be the one that never moves at all. But the opposite is true. A wing that cannot bend is a wing that has run out of ways to survive. This is where a single test rewrites everything you believe. Before any new airliner carries passengers, its wings are tortured on the ground in what is called the wing load test. Engineers clamp the aircraft down and pull the wing tips upward with hydraulic jacks, higher and higher, far beyond anything the plane will ever meet in the sky. Regulations demand the wings survive at least 150% of the maximum force expected in service. One moment in aviation history captures it. During the certification of the Boeing 777, engineers bent the wings upward until the tips had risen more than 7 meters. The wing finally failed at 154% of the required limit load. 7 meters. That is far beyond anything turbulence could ever create. The wing you watch flex a foot or two from your window is operating in the gentlest fraction of what it can endure. So the flexing that frightens passengers is not the wing approaching its limit, it is the wing barely stirring. A wing that did not bend would be the true warning sign. It would mean the structure had been built too rigid, storing danger instead of releasing it. Movement is proof the design is alive and working. The fear reverses the reality. The bending is not a symptom of weakness. It is the visible signature of enormous, tested, deliberate strength. And once you understand that, the view from your window will never feel the same again. So the next time you sit by the window and the wing rises toward the clouds, you will know what you are truly watching. Not a machine straining, a machine performing. That gentle arc is the sum of decades of engineering, spars carrying the load, ribs holding the shape. Carbon fiber skin flexing exactly as designed, absorbing every gust and every pocket of turbulence the sky can offer. Everything you feared has an opposite meaning. The bend is not the crack forming, the bend is the crack being prevented. Remember the numbers. A Dreamliner tip that rises 3 meters in flight. A 777 wing tested past 7 meters on the ground, a margin of safety built not for the average day, but for the worst day that will never arrive. Engineers did not design wings to resist the air. They designed wings to move with it, the way a tree survives a storm not by standing rigid but by swaying, letting the wind pass through its branches. Rigidity shatters. Flexibility endures. This is one of the oldest lessons in nature, and modern aviation is built entirely upon it. There is a quiet beauty in this. The thing that once made your stomach tighten is now the thing that lets you rest your head against the window and close your eyes. The wing is not fragile. The wing is honest. It shows you in plain motion that it is doing its job. So watch it bend, watch it flex against the light. And understand that this movement is not a flaw in the system. A bending wing is not a warning. It is the sign of a wing working perfectly.